Bismillahirrahmanirrahim. The last topic for this chapter, for your syllabus, is Bluetooth. And Bluetooth is also a wireless LAN technology. Okay? It will use the same frequency band as 802.11. They all share the same frequency band. But Bluetooth LAN is ad hoc. Okay? It's an ad hoc network. Devices come to form a network randomly. Okay? So there are two types of network in Bluetooth. We have piconet and we have scatternet. A piconet is formed between one primary and up to 7 secondary devices. Okay? So the maximum secondary devices we can have is 7. And including the primary, the maximum number of devices in a piconet will be 8. Okay? 8 devices in one piconet. These devices operate on the polling mechanism. So the primary is fully in charge, and the primary will decide who is going to communicate. Okay? And the secondaries devices will only communicate with their primary device. So these two devices may not, in one piconet, they will not communicate with one another. Okay, they will have to form another piconet for that. But in this case, you will have one device will only be under the control, one secondary device can only be under the control of one primary at any given time. Okay? They cannot have more than one primary device. So all these secondary devices are under the control of this primary device. And this primary device will use the polling mechanism to access the secondary devices. Now we have the parked state. Okay, what does this mean, the parked state? In the parked state, you could have more than one device sitting here. Okay, these devices have all formed a connection with the primary, right? They have all formed a connection with the primary. Okay, but these devices are not active. They cannot send any information. In order to send information, they will have to move to the active state. Okay? The devices here are active. So if they want to send something, they will have to move in here. So in this scenario, there are only 4 secondary devices. So you could have 1, 2, and 3 devices still join this network. They can join this network without any problem. But if all 4 of them now want to join, we will have to remove 1 device from these to add the 4, because we want to maintain the maximum number of secondary devices at any given time to 7. Okay? So in this case, if, for example, if we had more devices sitting here communicating with the primary, okay, if we had 7 devices in this piconet, we can't add more unless we remove one of these, and then we can add the other, okay? Because we have to maintain the maximum number of secondary devices as 7, and the maximum number of all devices in the piconet, including the primary, to be 8. We now look at scatternet. In the scatternet, you have in here, you have a primary, you have secondary devices in this piconet. And what did we say? We said one secondary can only be under the control of one primary at any given time. In this case, though, you could have one secondary device becoming the primary device for other devices. It is possible. Okay, so this device is a secondary device in this piconet. Okay, and this is the primary device who is in control. But this device is a primary device for the second piconet, right? And it is also controlling other secondary devices. So you have a larger network now, ad hoc network, and this is called scatternet. Okay? Every scatternet, every piconet will have an identifier, right? So that devices do not confuse with the primary devices. So every piconet will have a specific identifier. Now the Bluetooth layers that we have, at the lowest layer we have the radio layer, which is similar to the physical layer for the internet or the OSI model. Okay? The baseband layer will be similar to the MAC layer, and the L2 cap layer will be similar to the logical link control. Okay? The link layer, LLC layer in a normal network, in the internet OSI framework. Okay? So you should remember the mapping of how this would be. Now, the L2 cap data packet format. This is at the LLC level, right? This is at the L2 cap layer here. So you have the length field indicating the size of the whole packet. Okay? You have channel ID indicating the channel from the layers up, higher layers. Okay, they will have a channel, and this channel ID will indicate the virtual channel from TCP and the other layers. And you have the data and control bytes. Okay, so the data and other information will be in here. So this is the L2 cap packet. Okay. Now, let's look at how the transmission takes place in Bluetooth. It takes place in a TDMA fashion, right? Takes place in TDMA fashion. How does that take place now? First, let's look at the case where you have one primary and one secondary device, right? In here you have the primary, and in here you have the secondary device. These are the slots, TDMA slots that you have. Okay, time division duplex slots. Now, the primary device, you can have the maximum frame transmission duration in in this case to be 366 milliseconds, okay? Because this information will contain information for the hopping sequence and other details. So the data and the packet, the Bluetooth packet will have to be transmitted in 366 milliseconds. So how does the transmission take place? The primary device will transmit in even numbered slots. Okay, even numbered slots in time. And then in the next slot, the secondary will respond back. Okay, the secondary will respond back. So in the primary again, the even slot, the primary will send information and then the secondary will respond. And then you have multiple secondary communication. In this case, you have more than one secondary device that wants to send. Now, there is a rule in here, okay? In multiples, when there is more than one secondary device, you have to follow a certain rule. And the rule is that, again, of course, the primary will be communicating in the even-numbered slots, and the secondaries will communicate in the odd-numbered slots. However, in the even-numbered slot, the secondary that the primary can communicates with, only that secondary can respond back in the next odd-numbered slot. Okay, so in this case, the primary is communicating with secondary 1. So in the next slot, only secondary 1 will respond back. Secondary 2, 3, 4 cannot respond. Only secondary 1. This is polling mechanism. Remember with the polling mechanism that we had studied earlier, this is a kind of polling. So now in the second, in slot F2, the primary is contacting secondary device number 2, and then in the odd numbered slot, the secondary device number 2 responds back. Okay, so this is how the multiple secondary communication takes place. Now we are looking at the MAC layer frame format. You have in here the first 72 bits, they contain the access code, okay? And this access code is used for two purposes. You will have synchronization. So this code will help the secondary device synchronize with the primary device. Okay, the secondary device will synchronize with the primary device. And the second is identification. It will also contain the identifier of the piconet. Remember the ID we spoke about? Every piconet has an ID, we said. So this also contains the ID of the piconet. Then you have the header, and the header contains the address bit, which is 3 bits, and it is 3 bits only because the maximum number of devices that we can have in a piconet is 8. So 0 to 7. So the maximum number of bits that are needed to represent these 8 devices is 3. And then you have type, which tells you what type of information is coming from the layers above. F will indicate flow control. If this bit is set to 1, it means that the receiver cannot accept any packets. The buffer is full. You have the A bit, the A field, which is also 1 bit, and this indicates acknowledgement. And you have the S bit, which indicates sequence. Okay, and this also is 1 bit. And then you have the error correction, error control mechanisms, bits for error control, and these are 8 bits, right? So this is the frame format for Bluetooth. Now we have the function. How are these devices communicating with one another? You have different ways. In this phase, the first phase is the inquiry phase, right? Inquiry phase. In this phase, the primary device is advertising itself. Okay? It is advertising itself to the different devices. And these devices will respond with their address. Okay? They respond with their address if they want to join the primary device, the piconet. Okay? This is what's happening here. They're responding. So now they have responded and we have formed a piconet. So these green devices indicate that they are inside. Okay? Or rather, sorry, this is a second mechanism. Don't confuse this with the previous one, inquiry. Okay, this is in the inquiry phase. So you have established the communication with the primary device. Now in this phase, this is the paging mechanism. Okay, the paging mechanism. So one way in which the primary can know is to advertise itself. But in paging, what does it do? It will invite the devices one by one. Okay? It will invite the device one by one to join its piconet. The device, if it wants to join, it will send back an acknowledgement. Okay? The device will send back an acknowledgement. And then these green devices mean that they are now part of the piconet. Okay? These are part of the piconet. So this device is the master primary device, and these are the slaves or the secondary devices. And these are the parked devices. Okay? They have established the communication, the synchronization. They are linked with the primary, but they are not active yet. And these are the active. The green devices are the active devices. Okay? So there you go. You have the master, you have the active slaves, you have the parked slaves, and you have the standby devices. These devices aren't exactly connected to the primary device. So this was about Bluetooth technology. And with this, we have completed the chapter on wireless LANs.